Hello everyone, I am Professor Amit Solanki. Today we will discuss the topic which is name is chopper. So in that topic we will discuss about the definition and their classification of the chopper and their introduction about the chopper. So let us understand first their introduction. In that introduction part, we can see that the what is the definition of the chopper and what are their function. So a chopper is an static power electronic device that convert fixed DC input to a variable DC output voltage. That means our voltage or power directly, or we can say that the controlled DC output voltage. Simply, it is a DC to DC converter. So chopper is known as a DC to DC converter, or we can say that it converts fixed DC into variable DC. Chopper nothing but a high speed switch which connect and disconnect the load from the source at higher rate to get variable or chopped voltage at the output side. So this is the main phenomena function of the chopper. It is a high speed switch, and chopper can increase or decrease the DC voltage level at its output side. So chopper serves the same purpose in DC circuit transfer in case of AC circuits. So it is also known as DC transformer. So chopper is also known as DC transformer. In that block diagram you can see here, the main function of the chopper is that it converts fixed DC voltage to the variable output DC voltage. And this is the DC to DC converter. Also you can see here in this graph, in that there is the graph which shows the fixed DC input voltage, and output side we are getting the variable DC output voltage. These devices are also represented by the switch. It is represented as a switch in a dotted box for simplicity. So as you seen in this block diagram, in below, in this block diagram we have observed the symbol of the chopper. When it is closed, current can flow in the direction of arrow only. So device used in chopper, that is the low power applications like GTO, IGBT, power VGT, power MOSFET, etc. And the high power application like thyristor are SCR. So these are the used, or we can say that the application of this chopper. One is low power and second one is high power. So in that figure, you can see here, this is the diagram, switching diagram of the chopper. In that switch, you can see here, it is open and closed. So that is the symbol of the chopper. Now we can see that we can read the applications of chopper. In electronics, a chopper circuit used in power control and signal applications. So as we know that in the electronics part or electronics field, a chopper circuit is used in power control and signal application. Chopper used for DC motor control. It is a very big and very important operation or application of the chopper. That means with the help of chopper, we can control, we can manage the speed of the DC motor, or battery supplied vehicles, solar energy conversion and wind energy conversion. These are the applications of the chopper. Choppers are also used in electric cars, aeroplanes, and spaceship, where onboard regulated DC power supplies are required. These are the one more applications of the chopper. In general, chopper circuits are used as a power supply, like in computer, commercial electronics, and electronics instrument. So these are the all about the applications for the chopper. Okay. So as we earlier discussed the different concept, definition, introduction of the chopper, now we will go to the classification or type of the chopper. Generally, chopper is classified in two types. One is AC link chopper and second one is DC link chopper. So let us understand one by one the types of the chopper. In case of AC link chopper, or in the AC link chopper, the DC is first converted to AC by an inverter, and AC is then step up or step down by the transformer, which is then converted back to DC by the diode rectifier. So this is the main function of the AC link chopper. As a conversion in two stage, DC to AC and then AC to DC, AC link chopper is very costly, bulky and less efficient. So for that, this is very inefficient or very less efficient, which is the AC link chopper. In that figure, you can see here in this diagram, block diagram, in this AC link chopper, in that first signal is converted from DC to AC, then it converted AC into DC. That means these are having two steps. So for that, it is very complicated and very bulky. Now we are discussing about the DC link chopper. This is the most usable and important type of chopper. So in that you can see here. So this kind of chopper is more efficient as they involve one stage conversion. So DC link chopper have only one stage conversion, just like as a transformer, and the chopper can be used to step up or step down the fixed DC voltage. Okay, so we can use this chopper as a step up or step down the voltage, as looking like as a transformer. The chopper is also known as DC transformer. A chopper system has high efficiency, fast response, and smooth control. Okay, so chopper has a high efficiency, fast response, and smooth control. In that block diagram, you can see here, this is the block diagram for the chopper. In that you can see here in this block diagram, it converts DC to DC. That means here is one stage conversion of the chopper. Okay, so these are the type of the chopper. Now working principle of chopper, you can see here in this diagram what are the working principle, what are the function of the chopper. As we know that chopper is a semiconductor or power electronic devices which you have to convert fixed DC into variable DC. So in that you can see here in this block diagram we are showing here by the chopper is a switch. Switch is turn on and turn off periodically. In this way, constant voltage can be connected to and disconnected from the load. By a periodic application of constant voltage at a particular frequency across the load, variable voltage can be achieved by controlling the on period of the switch. This is the function of the chopper by a periodic application of constant voltage. So in that figure, in this diagram, you can see here is the switch is given, that means for connected or disconnected, and this is the load. Now we can find out the instantaneous voltage across load is either 0, that means switch off, or VI, that means input voltage, switch is on. So now we can find out the value of average output voltage over a cycle is the average output voltage over a cycle is, we can write here, V0 equals to T on upon T on plus T off into VI. So now we can write this equation V0 equals to T on upon total time period. That means total time period is given by, there is the combination of T on plus T off into VI. So we can write this equation V0 equals to D of VI, where D is the duty cycle or duty ratio. You can denote it is, in that figure you can see here, here is the switch closed, switch open. This is the figure, or we can say that the graph from V0 output voltage graph. This figure, this notation is shows that switch is closed. That means voltage is, output voltage is low. And this is the, at that time the output voltage is 0. That means at that time switch is open. So this will be process will be happen periodically one by one step. These are the basic concept, basic principle of this chopper. In that you can see here, as we know that according to the formula, so these are the T on and T off time, and the combination of T on or T off time, that is the total time period. Okay. Now output voltage varies linearly with the duty cycle. As we know that, as we already discussed, the formula for the output voltage, that is the V0 equals to D into VI, where D or delta is the duty cycle or duty ratio. It is possible to control output voltage from 0 to input voltage as duty cycle varies from 0 to 1. This is the main concept about that. This is the V0, that output voltage, and this is the duty cycle, that is the, okay. So in that the output voltage is very linearly with the duty cycle. Okay. So these are the all about the concept for the working principle of the chopper. So thank you so much for watching this video.